Hello, our dear student for the third preparatory stage. I wish you understand and interest in studying science. Science is very important for our mental development. Let's start our session today in the second unit, which is talking about lenses. Lenses. What meant by lenses? Lenses is a transparent medium made of glass or plastic, which has two spherical surfaces or two spherical faces. The lenses are formed of two intersected or union between two mirrors. The lenses will refract the light rays after falling on it. This is the definition of lenses. What are the uses of lenses? Lenses can be used in many fields, such as in medical eyeglasses manufacture for correction of the vision defects. Number 2, the magnifying lenses are used to fix watches, to magnify the small things. Number 3, in microscopes, to magnify images for the tiny objects can be seen by naked eyes. Number 4, in binoculars in wars, which is used by military forces. What are the types of lenses? Lenses have two types. Number 1, concave lens and the convex lens. The concave lens is this lens, which is formed by two spheres. It has two faces. This is the concave lens, which is thick from the two tips and thin at the center, while the convex lens is formed due to the intersection of two spherical surfaces, which is thick from the center and thin from the two tips of the lens. The concave lens will diverge the light rays or scatters the light rays after falling from it, while the convex lens will converge and collect the light rays after falling on it. The concave lens always has a virtual focus because it diverges the light rays, so the refracted light rays can't be intersected, while the convex lens has a real focus because it collects the light rays after refraction in a point called the real focus. Convex lens. This is the shape of the convex lens, which is thin at the two tips and thick from the center. The convex lens converges the light rays at a point is called the real focus. This is the convex lens. All light rays after falling on the convex lens, it will converge after refraction to form the real focus. This is the real focus of the lens. And how the convex lens work and form the real focus. This is the shape of the convex lens, which is thick at the bottom and thin from the two tips. The convex lens is a part of two spheres. This is the center of curvature. This is the radius of the curvature of the lens. This is the principal axis which passing through the optical center of the lens and the two centers of curvature. All light rays which are passing through the convex lens, it will refract and converge to form the real focus. This is the real focus of the lens. And this is the distance between the optical center of the lens and the focus, which is known as the focal length of the lens. This is two lenses. One is thick and the other is thin. The thick one will show small focal length as we see, but the thin one will show a large focal length. So the thickness of the convex lens will determine the amount of the focal length. The focal length of the thick one is smaller than the focal length of the thin one. Convex lens form a real image, and it can collect the light rays to burn the paper after collecting the sun rays. Also, the eye of the human or animals are formed from convex lens. Some concepts related to the convex lens. Number 1, the center of curvature of the lens, which is abbreviated by C, is the center of the sphere where this face is a part of it. This is the center of curvature, and this is another center of curvature, as we know that the convex lens is a part of two spheres. So it has two centers of curvature. The optical center of the lens is a point inside the lens placed on the principal axis in the mid-distance between its faces. This is the optical center of the lens. Lies on the principal axis of the lens between the two centers of curvature. The radius of curvature of the face of the lens, abbreviated by R. The radius, this is the radius of curvature, is the radius of the sphere where the face is a part of it equal half the diameter. We know that the radius of the sphere is half the diameter of this sphere. This is the principal axis of the sphere and the lens, which is the line between the centers of curvature of the lens passing by the optical center. The straight line which passing through the two centers of curvature and the optical length of the lens is known as the principal axis. This is the real focus of the convex lens, which formed by the intersection of the refracted light rays or the converged light rays. This is the concave lens. This is the incident light rays, which will refract and diverge. So we take the extensions to form the virtual focus, formed as the intersection of the extensions of the refracted light rays. This is a convex lens. The light rays falling on it will be refracted to collected at a point called the real focus. The distance between the optical center of the lens and the point of the focus is called one focal length. The focal length is the distance between the focus and the optical center of the lens. The cases of the formation of the image by the convex lens or the collective lens. The path of light reflected from a convex lens. If the light ray falls by the optical center, thus it completes its direction without any refraction. The light ray falls on the optical center of the lens, so it will pass without any refraction. Number 2. If the light ray falls parallel to the principal axis, thus it will refract passing through its focus. This is the light ray which passes parallel to the principal axis. It will refract passing through the focus. If the light ray falls passing through the focus, so it will refract parallel to the principal axis. This is the 3 paths of the light ray when fall on the convex lens. The cases of formation of the image by the convex lens. The first case, when we receive a light ray by using the convex lens. The position of the object very far like the sun. This far object will send parallel rays, parallel light rays, which is parallel to the principal axis. These rays will refract and converge to be collected at a point called the focus. The position of the image is at the focus point. Properties of the formed image: real and very tiny. The second case is when the object is placed at a distance larger than the radius of curvature of the lens, or after C. This object will send 2 rays. The first ray falls parallel to the principal axis, which will refract passing through the focus of the lens. The second ray will pass through the optical center of the lens, so it passes without refraction. At the point of intersection of these refracted rays, the image is formed. The position of the object at a distance greater than the radius or after the center of curvature, or more than double the focal length. The position of the image. The image stands at a distance greater than the focal length and less than double focal length, or between the focus and the center of curvature. The properties of the formed image. The formed image, we can see that it is small size, inverted, and real. The third case, when the object is placed at the center of curvature. This object will send 2 light rays, the first parallel to the principal axis, which will refract passing through the focus, while the second light ray will pass through the optical center, so there is no refraction. These 2 refracted rays will intersect under the point of C, so the image is formed. The position of the object at distance equal to the radius, or at the center of curvature, or at distance equal double the focal length. The position of the image at a distance equal double the focal length. What is the properties of this image? As we see, it is real, inverted, equal sized with the object. The case number 4, when the object is placed between the center of curvature and the focus of the lens. This object will send 2 rays. The first ray parallel to the principal axis, which will refract passing through the focus. The other one will falls passing through the optical center of the lens, forming an image after the center of curvature. The position of the object at distance less than the radius, or less than double the focal length, and greater than the focal length. The position of the image at a distance greater than the radius of curvature or greater than double the focal length. What is the properties of this image? This image is real, inverted, magnified, or large. Another case, when the object is placed at the focus of the mirror. This object will send two rays. The first ray parallel to the principal axis, which refract passing through the focus. The other ray will pass without refraction as it passes through the optical center of the lens. The position of the object at the focus. Position of the image. No image is formed as the two rays are passed parallel to each other. So no intersection of the refracted rays, so no image is formed. Another case, when the object is placed at a distance less than the focal length of a convex lens. This object will send two rays. The first ray is parallel to the principal axis, which refract passing through the focus. The other one is passing through the optical center of the lens, so no refraction. The two rays will pass away from each other, so we need to take the intersection of the extensions of these refracted rays to form the virtual image. The position of the object at a distance less than the focal length or between the focus and the optical center of the lens. The position of the image in front of the lens at the same side with the object. Properties of the formed image. Virtual, because it is formed due to the intersection of the extensions of the two refracted rays. Upright and magnified. The image formed by a concave lens is always virtual, small, and erect. As we see, the object is placed at any point in the principal axis of the concave lens. This object sends two rays. The first one is parallel to the principal axis, which will refract away, and the second ray which pass through the optical center of the lens, and so pass without any refraction. So the two refracted rays will not intersect. So we take the extensions of this refracted ray which intersect with the light ray which pass through the optical center to form the image. This image is virtual due to it is the intersection between the extensions of the refracted rays, and small as we see, and erect. Give reason for. The concave lens is known as diverging lens because it diverges the light rays after they pass through it. The image formed by concave lens is virtual because it cannot be received on screen as it is formed due to the intersection of the refracted rays extensions. We will try to solve some problems together. Show by a labeled diagram the formed image of an object put at a distance greater than the radius of curvature of the concave mirror and mention its properties. The body will be put on a distance greater than the radius of curvature. It means that the distance between the concave mirror and the radius is c. this body will be stand at a distance more than C, which is more than the center of curvature. First, we will draw the concave mirror. Then, we draw the principal axis. The distance between the point P and point F is called the focal length, and the distance between the point P, which is the pole of the mirror, and the center of curvature is the radius. The body will stand at a distance more than the radius. Here it is the object. This object will send two rays. The first is parallel ray to the principal axis. This parallel ray of the principal axis will reflect when hitting on the reflecting surface of the concave mirror to pass through the focus. The second ray passing through the focus, which will reflect parallel to the principal axis, and the image is formed at the point of intersection of the two reflected rays to be formed between the point of the focus and the center of curvature of the mirror. The properties of this image are real because it is formed due to the intersection of the reflected ray, and inverted and smaller in size than the objects. Another problem, show by drawing the position of the image formed by a convex lens to an object at a distance larger than the radius of curvature of this lens. Firstly, we draw the convex lens. Then we draw the principal axis of this lens, determining the position of the focus and the position of the center of curvature of the lens. The object stands at a distance larger than the radius of this lens. This object will send two rays. The first ray parallel to the principal axis, the second ray passing through the optical center of the lens. The first ray will refract passing through the focus, and the second will pass without any refraction. At the point of intersection of the two refracted rays, the image is formed. The image is formed at the point of intersection of the two refracted rays. The properties of this image. As we see, this image is smaller than the object, and it is inverted. Also, it is a real image it is formed due to the intersection of the two refracted rays. Another problem, a body of length 4 cm is placed at a distance 8 cm from a concave mirror. Its focal length is 4 cm. The concave mirror has a focal length 4 cm, so its radius is 8 cm. It means that the body is placed at the center of curvature of the mirror. Firstly, we draw the concave mirror, then the principal axis determining the point, the pole of the mirror and the point of the focus, also the point of the center of curvature. The body is placed at the center of curvature of the mirror. Then this body will send two rays. The first is parallel to the principal axis, which will reflect passing through the focus. The second ray will be sent passing through the focus, and when it hits the concave mirror, it will reflect parallel to the principal axis. At the point of intersection of the two reflected light rays, the image is formed. We see that the image formed at 8 cm from the mirror at the point of center of curvature. Its properties is real, inverted, and equal in size. Another problem, the object stands at a distance 3 cm of a convex lens whose radius 6 cm. It means that the distance between the optical center of the lens and the center of curvature is 6 cm and focus at point 3 cm. Find the image and its properties. Firstly, we draw the convex lens. Then draw the principal axis and the object. This object will send two rays. The first is parallel to the principal axis and the second passing through the optical center of the lens. The first ray refracted passing through the focus and the second ray refracted passing without any refraction. Here, there is no image formed by the intersection of the two refracted rays. We reached to the end of our session today. I hope you understand and interest studying with me. Goodbye. See you later in the next episode.